Hello, in this video we are going to see indifferent curves and budget constraint. Now we are going to see only an overview, and then in the next videos you are going to see this with much more details. Okay, we are going to use as a utility function the Cobb-Douglas function, which has this representation, and then if we change the transparency, we can see here that all of these curves here, for example this one, evaluate to the same value, which means that they have the same utility. So this is one indifferent curve and this is another indifferent curve, and you can see these indifferent curves here in 2 dimensions, and this label 2, 4, 6, 8 represent the value of the function in this point, that as you get closer to the corner you see that the function is increasing, because here you can see that as you get closer to the corner the value of the function is increasing. So in this case, let's start from the beginning, you see that it's symmetric, because if this utility function represents level of satisfaction, if I buy this quantity of good 1, let's say apple, and this quantity of good 2, let's say oranges, the level of utility is the same. So if I get more satisfaction eating apples, let's say good 1, then this value is, let's say, 0.7, and then here you see that this function grows faster when we increase this variable. And now if we increase the value of a, let's say from 0.5 to 0.8, then you see that the whole function goes up. And now we are in the context of microeconomy, so this utility function measures satisfaction. But when we use this Cobb-Douglas function in the macro context, then good 1 is going to be labor, G2 is going to be capital, and the utility function will be GDP, meaning that with the same amount of labor and capital, if we increase H, which represent technology in this case, the GDP will grow. So if we change from 0.8 to 1, then for any quantity of labor and capital the GDP will grow. But now we are in the context of microeconomy, so we're going to consider, let's say, apples and oranges, and this utility function is going to measure the level of satisfaction. So now let's go to the budget constraint, which is this one that we're going to see in detail in the following videos. So if we change the price, let's say the price of good 1, that here is 1, let's say that is 2, then we will see a shift here of this budget line, okay, this shift, and then we are going to see that if we want to see this line in this figure 3 dimension, then we can see this, and then we're going to see that if we increase the budget from, let's say, 10 to 16, then this line will shift out, and then this wall, this plane, will shift out too, okay. And then what we want to find is the optimal solution, which is the quantity of good 1 here and the quantity of good 2 here, that maximize this utility function subjective to this budget constraint. So if we take, let's say, 20, then this is the optimum. And we will find this optimum mathematically using substitution, which is the easiest method but applicable to only simple cases. And then we're going to see a more general method, which is Lagrange, that is more complicated but applicable to most of the cases. And we are going to see a graphical proof of the Lagrange method, and in order to do that we are going to see the concept of gradient, which is this vector here. And in order to understand the concept of gradient, we are going to explain partial derivatives, derivative of utility with respect to good 1 and respect to good 2, that are the component of this gradient. So you can see here that this long blue line is one partial derivative, and this shorter red line is the other partial derivative, and these two partial derivatives are the component of the gradient. So we are going to explain in detail this in order to show the Lagrange method. And finally, if you are familiarized with MATLAB, we are going to see two ways of solving this problem. One is using this function, which is the function that you use for constraint optimization, and genetic algorithm. This is easier but less general, and this is more complicated but useful for more general cases. Okay, so this is basically what we are going to show in the following videos. Okay, thanks for watching, and see you in the next video.